Alright, so the first way to do this, when you have limits and you want to evaluate it algebraically, we learned last year that sometimes you can do it by what's called direct substitution. There's no need to graph it or do a table. You can just substitute the number in. So for instance, you see this limit right here? I could just substitute 0 in, and guess what that limit's equal to? 0. Done. No need for a table or a graph. You just do it. Alright, take this one here. If I substitute 1 in, and I substitute 1 in, 4 over 2 is 2. Done, right? No. You'll have some of these on the test. You'll have some of these on the test, obviously, but then, this would be really boring if this is all we did. Oh, this would be really boring. Really, really boring. Alright. Okay, now we get into some trig. So we have to plug pi in and then do cosine of pi. Now we can do cosine of pi in two different ways. We could do unit circle. And what's the coordinates of that point right there? -1, 0. And which one's cosine? Is it x or y? X. That's cosine. That's sine. So it's -1, isn't it? So what's pi times -1? Negative pi. Right, the other way is to graph it. Okay, there's pi halves, and there's pi. It's -1. So you need to rememorize all your trig stuff. It is going to come back to us. Okay, and then the fourth and last one we can do by direct substitution. If you substitute 1 in here, looks like we're going to get -15 on top and -9 on the bottom. So that's going to be 5/3. So the moral of the story here is always try direct substitution first, because it might turn out to be an easy little problem like this. Then we get to the next two problems, and we see that direct substitution fails us here, because if I substitute 2 into this problem here, you get 0 over 0. Do you remember from last year what that's called? It starts with an I. In.
You could write it letter by letter.
Indeterminate form. Okay. Now, when you get 0 over 0, that's in calculus one of the what's called indeterminate forms. Now, here's what that needs to mean for you at this point. When you get an indeterminate form, that means you've got to do something. In other words, the answer is not 0, the answer is not 1. You've got to do something. Now, here are the do somethings that we're going to normally use in this chapter. The first do something is to factor. If that doesn't work, you sometimes can do synthetic division. If that doesn't work, sometimes you multiply by the conjugate. If that doesn't work, sometimes you multiply by the common denominator. And then there's some other little tricks. Sometimes we'll use a theorem to help us out. We'll learn something called the Squeeze Theorem. With experience, yeah, it sounds kind of weird. We have this thing called the Squeeze Theorem. There's this other one called L'Hôpital's Rule, and it looks like Le Hospital because it's French. But it's spelled Le Hospital, but it's L'Hôpital's. There's all these little tricks of the trade that you kind of have to know in case you have one of these indeterminate forms. So, let's start with this first one then. So let's go through our tricks of the trade. Can we factor this? Yes. So we have to review something from Algebra 2 and Pre-Calculus in order to factor it. And this is the difference of two cubes. We did this last year. It's a minus b times a squared plus ab plus b squared, right? And what happens is, if you take the cube root of x cubed and the cube root of 8, that tells you what to substitute into the formula. Alright, so tell me what to write down. Because that's a and that's b. I heard x minus 2 plus 2x plus 4. Right? So we reviewed this last year, and that is indeed how it factors. Okay, so now what do? You cancel. Good. Now what? Substitute in the number. Now do you notice I had to write the limit symbol on every step until I get to where I substitute. And then that's when I can just plug the numbers in and do it. Now another little trick on difference of two cubes, and we did this last year, is when you plug 2 in, you should have the same number. Yeah, that's exactly right. That's how you know if you did it right. If you don't get the same number 3 times, then you've done something wrong. You also could do this by synthetic division. Many of y'all did it that way last year. It's tomato tomato. For me, it's quicker to do this way. You might want to do synthetic division. For some, it'll be quicker to do it the other way. All right. So let's take a look at that second weird case problem that's on there, which is x minus 2 squared and what was it? Minus over x. And it's x approaches 0, I'm assuming. All right. Well, if you substitute 0 in there, trust me, you get 0 over 0. So you have to do something. Well, here again, the list I gave you, Jonathan, it's not a comprehensive list. Sometimes you may have to do something outside the box. Honestly, if it were me, I would do something on this that wasn't really listed, at least initially. Yeah, distribute. Let's FOIL and distribute and see what we get. Then I might factor it. Now, I could factor it as it is. There's a difference of 2 squares going on there, but I think I would distribute. So here again, another little trick of the trade from Algebra 1 and Algebra 2. Remember these formulas I tried to get you to learn last year about a minus b squared being a squared minus 2ab plus b squared? If I know that little rule, I don't have to FOIL. I can just write down what the answer is. So I'm hearing x squared minus 4x plus 4, and look what happens. 4's cancel, and then I can factor out an x. What's left in the parentheses? X minus 4. Now what? X's cancel. Can I substitute? Yes, I can. And I get negative 4. Could I have gotten these same answers by doing a table? Yes. Could I get these same answers by doing a graph? Yes. But if you don't have a calculator, those methods are for most practical purposes out of the window. Right. But traditionally, this is how we have done limits first. The other methods came really as technology came. But you have to know how to do them all three ways.